All right, so this is your last section before your test. We're going to look at proportions within triangles, but first let's look at a review. You're going to circle the model that can form a proportion with 10 to 15. So what are you going to do with number 1? What are you going to do with this one here? Because this is part to whole, isn't it? 10 to 15. So what's the part shaded?
6.
So there's 2, 4, 6 out of how many? Out of, oops, how did that get? I'm getting ahead of myself. So we have 6 out of 8. What does 10/15ths reduce to? 5 goes into both. So 5 goes into 10 twice, and 5 goes into 15 3 times. So what does 6/8 reduce to? So 2 goes into both of those. So 2 goes into 6 3 times, and 2 goes into 8 4 times. So 3/4 is not equal 2/3. So that one's not going to work. What about this one here? How many pieces are shaded? 4 out of how many total? 6. So we have 4 is to 6 as, reduce that, 2/3. So this one works. Let's double check on this one. What's shaded on the circle? 3 out of 4. And so that one does not work.
It looks like a pie.
No, swell. Swell. There we go. How to what? Forge? Oh, yeah, no. Okay. Number 2, circle the ratios that you can, shh, focus please. Circle the ratios that you can use to form a proportion. In other words, out of those 4, which ones can you put together to form a proportion? And if I were you, I would fully reduce them. Is 1/2 fully reduced? Yep. How about 3/4? Yes. What about 25/100ths? What does that reduce to? 1/4. So 1/4. And then, so that doesn't match either of those, right? And so what about 25 or 75/100ths? That's 3/4. So it matches this one, doesn't it? So there's your ratio. Today we're going to talk about bisector. What does a bisector do? It cuts something in half. It doesn't just cut something. It cuts something in half. All right? So it could be, a bisector could be a point, a segment, a ray, or a line. And technically it could be a plane as well. A plane could bisect another plane. Use the correct diagram at the right, or I'm sorry, use the diagram at the right, complete each statement with a correct word from the list below, and use each word only once. So for number 4, ray BD is the blank of angle ABC. So here's ABC. So BD is what? Is it bisects the bisector, or is it bisected? It is the bisector. Angle ABC is what by ray BD? It is bisected. And then ray BD blanks angle, it bisects. That was exciting, right? All right, so look at the next page. So Theorem 7.4, side splitter theorem, and its corollary. What does side splitter imply? Does it say splits the sides into equal pieces? Nope. So do you remember that when we were going over our homework today and in previous days, I just said right here we had a problem that we were going over that looked just like this triangle, where you have a smaller triangle that's overlapping a bigger triangle, and I said that you did not know that these 2 lines were parallel. Well, what is this diagram telling you here? That they're parallel. So an interesting thing occurs when you have 2 overlapping triangles. If 2 sides here are parallel, an interesting thing occurs. If a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. then it divides those sides proportionally. And so what it is talking about is this side here. If this side here is parallel to another side of the triangle and it intersects that triangle, and you can see where it intersects at RS, then it's saying that QR over QS, QR over QS is equal to RX over SY. And that's just one proportion that we could have. So we're going to draw a proportion, or we're going to make a proportion here. You can take QR is to QS as to RX is to SY. And that's just one proportion. And I chose on this proportion to go from left to right. So this proportion is done going from left to right. I could have very easily gone up to down, or right to left, or down to up. So let's do one more and just see if they give us equivalent proportions. So what if I did down to up? So if I start down, that would be here at RX, right? So if I start down, RX would be go up. What do you have? RQ, or I'm going to call it QR, just to remain consistent. That doesn't really look like a Q. Question, Bailey.
Why wouldn't it be XR?
RX and XR are the same. And I'm calling it RX because remember you can name a line segment with 2 points, but you can flip those 2 points. RX and XR are the same. And so then on the other side, what would be down on the other side? SY. Whoops, I want that up top. Up, I want that up top. I knew it was going to do that to me. Never mind. I'll fix it. It's not always the best, right? Okay, so SY goes up top. What's QS? And we're going to maintain QS. See? You never knew it. Now let's look at our cross products. The cross products here are QR times SY. Don't we have a QR times an SY here?
Yes.
And then on the other side, we have QS times RY. Don't we have a QS, I'm sorry, times an RX. A QS times an RX here? So aren't our cross products identical? Whether I went left, right, or down, up. And so there's two other proportions that we could have set up as well. I mean, we can still do this side is to this entire side as this side is to this entire side if you wanted to, but a shortcut is to just take the little pieces. They're proportional to each other. And so let's look at problem 1. So look at the diagram, and we're not going to go through their work, but let's just set up our own proportion. And typically when I set up my proportion, I will typically go from up, down equals up, down. I'll just look at these and say, oh, this right here looks like 1 fraction, and this right here looks like 1 fraction. Can't I set them equal to each other? That's not the only way that you could set them up. So we're going to do A is to A plus 4 as, so equals, 12 is to 18. Can I do something with the 12 and the 18?
Simplify.
I can simplify them. What goes into both 12 and 18? Higher than 2? 6. 6 goes into 12 twice, and 6 goes into 18 3 times. So really what I have is 3 times A equals 2 times A plus 4. Then distribute your 2, and we have 3 times A is equal to 2A plus what? 8. Then subtract your 2A, because we want to collect our A's on one side, and we get A is equal to 8. And the question says, what is the value of A in the diagram? Haven't we answered the question? That's all you're going to do. So we just have a new type or new way to set up a proportion in this particular section. All right, look at the next page. So problem 2, finding the length. This time, could I create a triangle here by extending this and extending this side? Could I create a triangle? And so wouldn't these parallel lines here be side splitters to the triangle? And isn't it splitting this side of the triangle and this side in the triangle? And so the question says 3 campsites are shown in the diagram. What is the length of site C along the road? So they want to know, what is this length? So I'm going to let that length be X because it's my unknown. And so again, I'm not going to go through their problem there. But I've got, I have this 9 yards I could do something with, but do I have anything across from it? Nope. So I have 8 yards and 7.2 yards that are across from each other, so that's a full ratio that I could set up. And then I have the 6.4 that corresponds to site C, which we've called X. So we're going to use these 4 in our proportion. So let's set up a different proportion than they have. So we're going to take, let's go from up to down, because it makes sense. I'm going to look at this as one fraction and this as one fraction and set them equal to each other. And so I have 8 yards is to 7.2 yards as, so equals, 6.4 yards is to X. And so cross multiply, we get 8X is equal to, and then we're going to multiply the 7.2 times the 6.4, and we get 46.08, and then divide by 8. We get X is equal to, and obviously for a problem like this, I would assume you're using a calculator, 5.76. And is that chicken livers, oranges?
Yards.
Oh, yards, thank you. And so that is the question, or that does answer the question. So you should have a therefore statement with this because it's a word problem. Therefore, the length of site C along the road is approximately 5.76 yards. And then I think I'm going to stop there for today. And you won't be able to complete all of your homework. So if I were you, tonight I would complete my review portion of the homework, which is the 51 through 64, and complete any part of the homework that deals with side splitter questions.
So you could actually put like 7.2 over X equals
Absolutely.
6.4 as long as it's the same.
Yes, you could do 7.2 over the X equals, and the 8 corresponds to 7.2, so it'd have to be 8 over there. Correct. So we could have gone left to right, which is what you're doing. All right, so if we look at Theorem 7-5, the triangle angle bisector theorem, it essentially says, or does, the same thing as our previous theorem did, except for look here, you've got an angle bisector. I know it's an angle bisector because of the notation showing that this angle is bisected. And this bisector hits this opposite side. And what this theorem is saying is if you have an angle bisector, then these 2 pieces here that the bisector cuts, and it does not cut the opposite side into equal pieces, but what it does is it cuts this into proportional pieces to these sides. So the 2 sides that the angle bisector is not touching are proportional to each other. So you could set up a proportion of this side over this part equals this side over this part, so you could go up, down. Or you could go left to right. This side is to this side as this piece is to this piece. Or you could go right to left, or you could go down to up. So there's 4 different proportions you could set up. This is just one of them. Ellie, come up here and get them. What, were you here yesterday?
No.
Okay, so when you guys are absent, you have to come talk to me. All right, so, and also furthermore, when you're absent, you're supposed to watch the video from what you missed. So nobody emailed me that it wasn't online last night, which tells me that we didn't look for it.
I did.
Uh-huh. Right. Okay, so let's look at problem 3. Shh. Let's look at problem 3. So as you can see, they don't have to tell you, but I have an angle bisector here. And it's bisecting this side, and as you notice, the side's not equal. There are several different proportions we could set up. So I'm going to set up a couple of them. So you could have y is to 9.6 as 24 is to 16. So I went from top down. Or you could go from left to right. We could do y is to 24 as 9.6 is to 16. So let's just stop and look at these two for a minute. Isn't the y and the 16 cross products? And the 9.6 and the 24. And same thing here, the y and the 16 are cross products, and so is the 9.6 and the 24. And then both of these could be flipped. So in other words, I could have gone from bottom up, or I could go from left, or did I do left to right? Or I could go right to left. So the only thing that would change is these would be reciprocals of each other. Yes?
Do you want the answers in decimal or fraction?
If there are, that's a good question. So if there are decimals in the original problem, you can have decimals as your answers. So for this one, let's go ahead and find our cross products. We're going to ignore what they have over here. So find our cross products. Y times 16 is 16y equals, and then we're going to find, using our handy dandy calculator, we're going to find 24 times 9.6, which is, yep, 230.4. Then you're going to divide both sides by 16, and you get y is equal to 14.4. And so that's that should take care of any of the problems that you weren't able to do last night. So you cannot do this if you don't have an angle bisector. So make sure that you have the proper notation for that. And then let's look at the last page. So I want you to look at the lesson check. The lesson check is interesting. You have to decide which of the two theorems that we've gone over in this section that you can use. So I want you to go through number 17 and then number 18. So do those. I'm going to do them quietly up here while you do them at your desk. Are you done? Thank you. So what proportion did you choose? The first, second, third, or fourth? Because I want you to solve the correct proportion before you go on. So you had to have chosen a proportion. Which one? First, second, third, or fourth? Third is not correct. Second is not correct. First is not correct.
Fourth, of course. I mean,
And so I have made the proper corrections here, and you need to be really careful. Look what they've done. So on the picture here, the whole distance here is 45. And so I took 30 from 45 and got 15. So this piece is 15, this piece is 30. These pieces are proportional to each other. You can never go diagonal to them. So you can't say 15 is to 10. You can't put 15 over 10. You can't go diagonally. You can go this way, and you can go this way, and this way. But you cannot go diagonal. So look what they did here. If they did 10 is to 30, so that's 10 is to 30, they're going right to left. You had to do x over 15, and they put x over the whole amount, 45. Because you have to do pieces. This is a piece, that's a little piece, that's a little piece. And then for number 2, it should have been 15 over 30, because if they're doing x's to 10, so now they're going bottom to top, if you will. So they're going x is to 10, so that means they had to start here at 15, because that corresponds to x is to 30. And then for this third one, it becomes a little bit more complicated. They took x over x plus 10, so that's this side on the small triangle, because here's your small triangle. And then they did the large triangle. So they're going back to what you learned before this section, when you have overlapping triangles. So they did this side corresponds to this side, which is x plus 10. So then you have to do this side over here, which is 15, corresponds to the whole big side on the big triangle of 45. Did I? Yeah. Oh, I put 14. How odd is that? Let's fix that to 45. And I can't, of course, erase it. So let's make that 45. And then finally, the fourth one actually works because they've got 10, which is this piece, is to the whole side. Oh, you can't use that. Is to the whole side. Interesting. Well, it's still not the second. 30 is to 45. X is to 10. Nope. Huh. Did I look at one of these wrong? 10 is to 30 as x is to 15 it should be. So x is to 10 as 15 is to... The problem is x and 30 don't match, and then here, I don't know, I guess this doesn't match the rule. I would never set it up this way. But they are doing 10 and 30. I suppose 10 and 30 could correspond to x plus 10 and 45. I probably wouldn't have done that, so let's go ahead and solve that. I would never set it up that way, because now you're combining both of them, but it should still work, technically. So let's go ahead and solve that proportion. So you've got 10 is to x plus 10 as 30 is to 45. What do you think you should do with that 30 and 45? Because those are pretty big numbers. I'd reduce them. What goes into both of those? Biggest number?
15.
15, very good. So 15 goes into 30 twice, and 15 goes into 45 how many times? 3 times. So you continue to solve on your own. And then share with those around you what you get. What'd you get for x? Cinco? 5? How can we check and see if it really is accurate? If this, because this is a weird way to set up a proportion, because I probably would not have set it up this way. How can I check to make sure it works? Plug it in and then do what with it? So if x is 5, if x here is 5, couldn't I set up a proportion of 5 is to 15 as 10 is to 30, let's say? I sure could. So 5 is to 15 as 10 is to 30. What does 5/15ths reduce to? 1/3. What is 10/30 reduced to? So they are equal. So it does check. Okay, so then last but not least, let's do the lesson check. It says a classmate says you use the side splitter theorem to find both x and y in the diagram. So a side splitter just means that you've got these two parallel lines here, and they're splitting these two sides of the triangle up into proportional pieces. So explain what is wrong with your classmate's statement. So you're going to go through questions 19, 20, 21, and 22. So do that on your own. I want you to find the value of x and y, by the way. Are we good? So let's look at what I wrote up here. So for question 19, would you agree that 7 and x, these parts are not parts of the sides intersected by the parallel line? Because they are on the parallel lines, right? And so you can use these 4 to set up a proportion. I happen to set up a proportion down here for y using those 4. It's not the only proportion, but your cross product should be identical to mine. So however you set up your proportion, your cross product should have been 3y and 4.8. So that when you divide by 3, your answer for y turned out to be 1.6. And then question 20 says, can you use the side splitter theorem to find x? No, because x is not on the sides that are split by those parallel lines. And so the answer to that's no, but you can use it to find y, which is exactly what I used here to find y. And so my response was, since x is not a piece of the sides of the triangle that are split, you cannot use the side splitter theorem to find it. So instead, I used our corresponding sides to similar triangles. How do I know that the triangles are similar? By what theorem? I don't know enough about all three sides because I don't know x. And I don't know that y yet. So I can't use anything with s in it.
AA.
Why?
Because,
Those are parallel lines.
the parallel lines can
So you
just-
got parallel lines, right? So wouldn't this angle here and this angle here, their corresponding angles, wouldn't they be congruent? And then this angle here and that angle there are also corresponding, so they're congruent. That gives you 2, but you could also say that the two triangles overlap at this top angle here, so they share that angle. That's congruent as well. But you only have to find 2, AA. So by AA, they're similar, and so I set up a proportion of similar sides. Where did I get the 5 from? So this side is 2, the corresponding side on the big triangle is this side, you have to add them together, that's 2 plus 3, that's where the 5 came from. And then I use the bottom of the triangle x and this whole bottom 7, and so you get 14/5. Could you have changed that to a decimal? Yes, because there's a decimal in the original problem. Okay? Any other issues, problems, or concerns with this section? All right, so look at your workbook. So go to page 199 in your workbook. Didn't I already ask you to get your workbook? Why are we getting up? All right, I want you to look at questions 1 through 6 because I want to make sure certain things are clear. So here's the picture for 1 through 6. And so I want you to look at the questions, the proportions, and I want you to fill in these proportions. A is to C as blank is to F. And then we have F is to E as C is to blank. And then blank is to C as E is to F. A is to blank as B is to E. And 5, A is to B as blank is to E. And finally 6, E is to blank as F is to C. So they've got A is to C. So notice that we're skipping, and some of you had questions on your homework last night regarding this. You can go all the way from down here to here. What you can't do is go diagonal. You can't go diagonal here, diagonal there, but I can go from here all the way to here. So if A is to C, notice that F corresponds to C, so that's why those are in the denominator. So what corresponds to A? D. So you should have D here. And then next we have F is to E, so we're going bottom up. So the other proportion should be what is to what? F is to E. What's the other side? What corresponds to F? C, which is what they have here. C is to B. So I shouldn't have to give you I only have to give you 2 parts of the ratio on one side, and you ought to be able to figure out the whole other side. And then for 3, the right side they have E is to F. So what should the left side be? B is to C. And then for 4, B is to E. So B is to E. So what is the left side going to be? Yep, it's going to be A to D. They could have done C to F, but they're going to do A to D. That's a lovely D. I'm not erasing it. And then for 5, A is to B. So what's the other side? D is to E. And then finally, for number 6, F is to C. And they have E, so it has to be to B. All right? And I have one more that I want you to look at. I want you to do, actually I have 2 more. I want you to do 14. So you do that on your own. So set up your own proportion and solve. Tell me when you have issues. Is this a true proportion according to the angle bisector theorem? The angle bisector theorem says that if you have an angle bisector, the side that that angle bisector touches is proportional to the other 2 sides of the triangle. So couldn't I go 3 over x equals x plus 2 over x plus 4? What I can't do is go diagonal. I cannot do diagonal. And look at my cross products here. If your cross products are going to be the same as mine, you set up a correct proportion because there's 4 of them that you could set up. So if I look at my cross products, I've got 3 times x plus 4 equals x times x plus 2. Go ahead and distribute. You get 3x plus 12 equals x squared plus 2x. Doesn't that imply that we're going to factor? Bless you. And again. And so I'm going to, this is my highest degree term here. So it's positive, so I want everything on this side, so I'm moving everything from the left to the right. So I'm going to subtract 3x, and I'm going to subtract 12. If you subtract 2x, then you're putting everything on, or you're putting this over here to the left side, and that means you subtract the x squared, and we like our highest degree term positive. So I always focus on the highest degree term, so I don't always put everything to the right or the left, it just depends. Bless you. And so we end up with 0 equaling x squared. This gives you minus x minus 12. So this is the easier factoring, where we want the factors of 12, and it's easier factoring because there's no coefficient from the x squared term. But I want the factors of 12, it's negative, so that means I'm going to subtract the factors of 12. You're blessed forever. I want the factors of 12 that subtract to give me a negative 1. So don't worry about the fact that it's negative. What factors of 12 subtract to give you 1? 4 and 3. So I know I have an x and an x here, because x squared splits into that. And then I have a 3 here and a 4 here, or vice versa, it doesn't matter. Let's focus on our signs. So if I want a negative 1, the bigger of these 2 have to carry that sign. So that means the 4 becomes negative. What does the 3 have to be for those 2 to combine to give you a negative 1? Positive. If the 3 were negative, they would combine to give you a negative 7. And so we don't want that. So then don't you set x plus 3 equal to 0 and x minus 4 equal to 0 to solve? What can x equal? Negative 3 and positive 4. Is x able to be negative in the picture? No. So that's extraneous. We throw that out. And our only answer is x is 4. Okay? And then the last one that I want you to do is number 16. So no matter what proportion you set up for this one, your cross product should be the same as mine. So I choose to go top down, so I'm going to go x plus 4 is to x minus 2 as 3x is to x minus 1. I just went top down. So when I have cross products, I've got a 3x times x minus 2 equals x plus 4 times x minus 1. So we have a lot of multiplying to do. So you're going to distribute your 3x into the parentheses, and so you get 3x squared minus 6x equals, then you've got a FOIL here. Multiply the x to everything inside the parentheses, so you get x times x is x squared, x times negative 1 is negative x, and then we want to distribute the 4 into parentheses. And so we get 4 times x is positive 4x, and 4 times negative 1 is negative 4. So focus on your highest degree term. Don't we have 2 of them? Which one's bigger? Which one's bigger? The 3x squared. So I want, and it's positive, so I want this here to stay and remain. So that means that everything has to come over to that side. So we're going to subtract the x squared. We're going to, don't these two together make 3x? So I'm going to subtract 3x and subtract 3x. And then finally I want to add 4. So I'm just going to kind of add 4 down here somewhere. I'm going to write my left side in descending order. So 3x squared minus an x squared is a joyful 2x squared. Add your plain x's, you get minus 9x, and then plus 4 equals 0. So this is a harder factoring. Well, we're adding 2 negatives. We don't usually subtract. Don't view it that way. And so you want to take your bookends, your 2 and your 4, and you want to multiply them together. 2 times 4, doesn't that give you a positive 8? Right? And so I want to know what factors of 8, because it's positive, add to give me my middle term. Well, my middle term is right here. It's a negative 9. So I want to find the factors of 8 that add to give me a negative 9. So don't worry about signs. What factors of 8 add to give you 9? Well, don't worry about signs. So 1 and 8 do add to give you 9. Agreed? And so I do want my 9 to be negative. So always the bigger of these two will carry the sign of that middle term that we want. And so because 8 is bigger, it carries the sign of the negative. And then you have to decide, does the 1 have to be positive or negative to make a negative 9? Negative. So then tack on your variable, your middle variable, into here, because we are replacing this middle term with those 2 terms. And so here we go. So we're going to take the bookends, 2x squared, and we're replacing the middle terms, minus x, minus 8x. So we're replacing that negative 9x with it. And then our last bookend is a plus 4 equals 0. Once you have those 4 terms, you're going to split the 4 terms in half right there. So you have 2 and 2. And then I want you to look at the greatest common factor for each of those pairs. Look at the first group. What do they have in common? An x. So you're going to factor an x out in front of parentheses and divide each of those by an x. What do you have left? 2x squared divided by x. 2x. What's x divided by x? 1, and it is a negative 1 because there's a negative in front. Then anytime your third term is negative, 100% of the time you're going to factor out a negative, because notice how this term is positive. When I factor this, I need it to come out positive. So I know I'm factoring out a negative. What does the 8 and the 4 have in common? A 4. So I'm going to, bless you, and again, I'm going to factor out a negative 4 from each one of these, so I'm going to divide each one of those by negative 4. So what is negative 8 divided by negative 4? Positive 2x, and then positive 4 divided by negative 4? Negative 1. Do you see how what's in parentheses is identical? That's what we want. So we're still not done factoring because we have subtraction outside of parentheses. So we're going to take this identical greatest common factor out in front again. 2x minus 1 comes out in front of parentheses. And then essentially we're dividing each of these by 2x minus 1. Do you see how those cancel? And what you have left, the x and the minus 4, they get thrown in the empty bin, the empty parentheses next door. So we're factored. So hopefully you took good notes so you can follow that again. And so then we're going to set each one of those factors equal to 0. So 2x minus 1 equals 0, and x minus 4 equals 0. So we're going to add 1 and divide by 2. And here we're just going to add 4. Can x be 4 in all of the expressions? Yes. Nothing, if x is 4, nothing here becomes negative. What if x is 1/2? What happens here? A negative. What happens here? A negative. So we actually have to throw x equals 1/2 out because it's extraneous. It doesn't work in this real life situation. So we don't always throw out negative answers. Sometimes we throw out a positive. You have to go back and check and make sure. Because the problem we set up doesn't understand it's a triangle that has positive sides only.